Okay, our last team of this session is team number 14, DictionBeary.
All right, hi everyone, we're Team DictionBeary and my name's Tarana.
I'm Dean.
I'm Cody. I'm Christine.
Brandon.
And our project is an open source translating teddy bear. And as the world is becoming a rapidly smaller place, one of the communication barriers that still exists is the language barrier. And studies indicate that young children are most adept to learning a new language. Our project is an educational tool that helps children learn new languages, conversing and interacting with an interactive plush toy. Additionally, our project is open source, so we hope that others will help contribute to it and help move our initiative forward. So these are some of the key features of our project. It is USB rechargeable and has Wi-Fi accessibility. Parents can monitor their children's progress through an accompanied dashboard, and it operates in 3 modes. One, conversing in the learning language, conversing from primary language to a learning language, and direct translation. It's designed for children ages 3 to 7, and it is accompanied by an Android phone that displays emotional GIFs based on the conversation. Current implementation includes English, Spanish, French, Italian, and limited implementation of Russian and Persian. And the bear responds within 7 to 10 seconds. And for our demonstration purposes, we've kept, it enters a low power sleep mode after 20 seconds, which we've kept at 20 seconds for demonstration purposes. So, and here's what our final product looks like right now.
So here we have a block diagram of our whole system put together. You can see that our development board is powered by a battery. Our Android phone allows you to choose what mode of operation you want to be playing in and which child is using the phone right now. And it also displays emotion based on what the bear is feeling. The child speaks into the microphone, which is then sent through our speech-to-text module. That is either sent through conversation or translation. That is then sent to our dashboard, which is updated with metrics. You can also change the language that the child is speaking or learning on the dashboard. And then based on that response, that's sent through our text-to-speech module, which is then sent through our speaker. So here's a list of the hardware that we used. Our development board was a BeagleBone Black running Linux Debian. It doesn't have Wi-Fi on the board, so we did need a USB wireless adapter. In order to make the board USB rechargeable, we're using an external battery. The board also doesn't have auxiliary ports, so we are using a USB to auxiliary audio adapter in order to plug in the microphone and speaker. We actually went through 3 speakers trying to find one that was loud enough and also fit inside a teddy bear, and so we ended up going with one by Avio. And we are using a condenser computer microphone as well. We also have 2 bash scripts on the board, one that runs at startup to run our program, and then one that puts the board in power save mode. We also have 2 3D printed cases. One is inside the bear, it holds all of the internal hardware, and then one houses the phone case outside of the board.
So for our translation module, we're using AT&T's speech-to-text API for the speech-to-text. We're using Microsoft Translation API for the translation. And we're using an open-source C-based program called eSpeak for the text-to-speech portion. So what happens is as the child uses DictionBeary, we record a WAV file, which is sent to our AT&T speech-to-text API. We then pass this text to be translated to the Microsoft Translation API, which takes a string and the source and target languages as parameters. And then we receive the translated text, which we use eSpeak to create and play a WAV file. In order to transcribe speech-to-text properly, we had to use the AT&T speech-to-text custom API, which requires dictionary and grammar files, which basically map words to their proper pronunciations in the given language.
So one of our customer requirements was for the child to have a conversation with the bear. So conversation is handled by the NLTK in Python, which is the Natural Language Toolkit. It's for natural language processing within Python. You're able to get the sentence or the string from speech to text, and you're able to parse through that sentence and you're able to essentially get emotional words that we find or we list in a library/dictionary, and we take those and we send it to the phone that you're able to display an appropriate emotional GIF on the phone. The response is also then sent for either translation, depending on what mode it is, or directly to text-to-speech for speech.
So the Android app is currently being run on an LG Optimus XC2, and the board begins in a low power mode, so the phone begins by waiting for the child to shake it. Once the child shakes it, it tells the board to run startup script so that it can begin listening for any speech. But before that, the child must choose who's playing, and he gets this based on who's registered on our online dashboard. The phone displays buttons based on who's registered, and the child then selects his or her name. After that, the child can select what mode he wants to play, and then after that, based on the context of the conversation between the bear and the child, emotional GIFs are displayed.
So as the child is playing with the bear, we keep track of what words are being said, how many times they're being said, and when they're first being learned. Once you register your bear using the unique serial number attached to the bear, parents can then log into our cloud dashboard, which is hosted on Amazon Web Services, Elastic Beanstalk, and they can view all the metrics individually by child and language. So they can see the frequently used words, words learned and spoken, and a graphical representation of their daily progress. Additionally, they can also see an overview, seeing how the bear is utilized by all of their children, as well as for each child, they can see how they're using each language. As mentioned by Brandon and Cody, you can also change child settings, such as their learning language and their native language, as well as add children and delete children attached to your account. We're not going to show a video of Cody using our bear. She's going to be talking to it in English, and she's going to get a response in English. You can see the bear is going to greet her as Cody, and afterwards you will see the dashboard in use.
My name is Cody.
Hi there, Cody. I'm sure happy to see you. This is Alexander.
That's awkward. So our customer was Professor Kia. We did our customer installation last week on Tuesday. He said that he was quite happy despite that we had limited implementation of Persian and Russian, but he said he was pretty cool with that. Additionally, we did test our bear with a 4-year-old. Unfortunately, our video wasn't of him playing with the bear because he was more fascinated with his mom playing with the bear, but he was totally happy seeing the bear interact with his mother, and he liked that it was talking. So in conclusion, as we develop more technology to bring the world closer, we can still only communicate as far as we understand each other. We hope that this product helps break down language barriers and educate kids throughout the world by providing a conversational buddy in the form of a toy. We still have a lot of work in terms of the accuracy of the speech to text, as well as the latency, as you can see from the video. But we hope that this product continues to grow as future design teams work on this project. Also, by making it open source, we hope that people work on this initiative to make a more accurate product. We'd like to say thank you to the ECE department for all of their help, as well as all of you for being here and listening to our presentation. That concludes everything. That's all. Any questions?
So for an open source product, how do you plan on handling the case when your APIs that you're currently using suddenly do not become free, such as the AT&T one and the Microsoft Translation API?
So, funny story, the AT&T speech API is actually being taken down after this essentially after this project's done. It's what, in December, I believe?
Yeah.
So unfortunately, speech to text will not be working on our end. We currently have so originally we planned on using open source versions of speech to text, but they seem to be too complicated or too unnecessarily hard to train. So we eventually went up with the API, but there are open source versions of what we have. So we would probably look into that and see implementing them in order to make it fully open source.
What about the case of the Microsoft translation API? As I know, I think that is the last remaining free translation API.
So I don't know. I am not sure about the APIs or open source libraries that may be able to replace that, unfortunately.
Something that could happen in the future is like a database full of translation words could be created, basically make our own API. That's something definitely for teams further down the road to take a look at.
What was a key factor in latency, and were you able to shorten that from the previous benchmark?
So our original plan was to run everything in Java, but it proved our latencies would go from I think it was 10 to 20 seconds. We switched to Python. There was a REST implementation of the API, the AT&T API, which brought our latency down to basically 5 to 15 seconds, depending on different factors such as what language we're using, depending on how long the sentence is. I believe another key factor is the internet speed. But what was our original requirement?
7 seconds.
7 to 10 seconds, and we basically meet that depending on how long or how bad, I guess.
Yeah, we were
it
originally
functions.
testing our product using a cell phone hotspot because we can't connect to BU Enterprise's Wi-Fi, and that definitely showed that our latency was up to 15 seconds using that. So internet speed is a large contribution to the latency.
Yeah, I just wondered, a sort of philosophical question, do you have any thoughts about how, if this were out in the world, people would react relative to privacy concerns?
We weren't too concerned about privacy since it would be mostly children playing with the bear.
Well, that's what we tell them.
Okay. We currently don't have any implementations of security, but that is definitely something to look into.
Yeah, we didn't think about that. We thought it would just be a parent product.
Okay, thank you.
Yeah.